Okay, Foundation of Pre-Cal 10, here we go. We are going to look at videos of non-linear equations, which are equations that are not straight lines. So in some respect, in some sense, these lines will curve. So there is a dead giveaway as to what is a non-linear equation, and it is when we have exponents on our x and our y that are greater than 1. Okay, any or less than, but in this case, we're really going to focus on greater than. So unless your exponent is a 1, like on our classic slope-intercept form, right? We have x power 1, y to the power of 1. Then we're going to have a curved line. Another thing to identify in this is this negative means negative 1 times x squared plus 5. That negative is independent of that exponent. So the best case scenario for grade 10, because we haven't learned these in depth, is just to create table of values. And what we do here is we are just going to plug values in for x and see what happens for y, and then we can hopefully see the behavior of the graph kind of coming into form. So let's start with x equals 0, because x squared is 0 when x is 0, so that's great. Otherwise, since we have x squared, consider the fact that a positive number squared and a negative number squared are both positive. So we want to try both positive and negative values of x. So let's go to 1, -1, 2, -2, and see if we can start to identify some behavior. So when x is 0, what do we have? When x is 0, we have y equals 0 plus 5. So y is 5. So there's a point on our graph. When x is 1, we get y equals negative, I'll do it as a -1 so we don't get confused, times 1 squared plus 5, which gives us 1 times -1, so -1 plus 5. So we get 4. Well, what about if x is -1? The only thing that changes here is that becomes -1, but -1 squared is still 1, and then 1 times -1 is still -1. So we end up with the same value. Same thing's going to happen here if we change our x value now from 1 to 2. Well, what's 2 squared? 2 squared is 4, but then times -1 is -4, and we'll get 1. But then we're going to see the same thing occur if this is -2, because -2 squared is 4 times -1. So again, we get the same value. So what does this look like then on my graph? It means I have a point here at 0, 5. It means I have a point at 1, 4 and -1, 4. And it means I have a point at 2, 1 and -2, 1. So I have an upside down parabola. This is called a parabola. It's a U-shaped graph. You'll see it a lot in grade 11 and probably a bit more in grade 12, but it's a shape to get used to. We're going to learn how to graph these things in a bit more of a simplistic way in grade 11, but right now the focus is to just plot points and determine behavior of graphs. So now this next one here, this is what we call a rational equation because it's a big fraction. And in this lies an issue. We are not allowed to ever see this scenario. We can't divide by 0. So that means when this bottom part is 0, we have a problem. That means when x minus 3 equals 0, we have an issue, and that occurs when x is 3. So what that means is x is not allowed to be 3. It is outside of our domain. So we have a asymptote. It's called a vertical asymptote. Again, this is a precursor conversation for grade 11. But what this is a line that we are not allowed to touch. X does not exist there. So what we want to do here is we want to check the behavior on either side of that. So let's check when x is 1, when x is 2, when x is 4, when x is 5. Let's start there. You can see we left out 3. So when x is 1, what do we get? We get 1 over 1 minus 3, which is 1 over -2. So we get -1/2. What about when x is 2? Well, when x is 2, we get 1 over 2 minus 3, which is 1 over -1, which is -1. So we have -1. Now when x is 4, we get 1 over 4 minus 3. So we again get 1 over 1. So we get +1. And then when x is 5, we get 1 over 5 minus 3. So we get 1 over 1/2, but +1/2. So you can see some similar things happening here, but what does this look like graphically at this point? It means when x is 1, we're at -1/2, so we're right about here. And when x is 2, we're at -1, so we're actually heading in a downward direction. Now, if you look at this 1 over x minus 3, this graph will never equal 0. Y can never be 0 because there's nothing you can divide by to give you 0. In order to have 0, the top would have to be 0. And since the top isn't 0 and can never be 0, that y equals 0 is not a potential solution. So what does that mean? That means we have what is called a horizontal asymptote through the x-axis, because that is a horizontal line, y equals 0. So that means my points there that I have labeled in black, as x, let's just see what happens as x went to 0, because as I move away, right, from the asymptote, I get 0 minus 3, which is negative 1/3, which means I'm getting closer and closer and closer to 0, but I'm never actually going to touch it. So my line goes like this. And then what happens after here we'll do in a second. Now on the other side, we have when x is 4, we're at 1, and then we're at a half. And then if x were 6, we'd be at a third. And you get the same scenario. It's going to get infinitely close to that point, but it's never going to touch it. So all we got to check and see here, and this can be a confusing aspect, so please bear with me, is what happens as we get infinitely close to 3 from either direction. So we'll use an example. They say that 3 plus means getting infinitely close to 3 from the positive, so from this side. So that means we have something like 1 over 3.00001 minus 3. So you can see my x value is now getting infinitely close to that point where it is not allowed to exist. And what do we get? We get 1 over 0.00001. Now, if you divide 1 into an incredibly small number, try it in your calculator, you get an incredibly large number. Because this is 1 over, this exact example would be, 1/100,000th. So we have this. And if you remember your fraction work, we're dividing by a fraction, we can flip and multiply. So we actually get 100,000 for y. So as you divide by an infinitely small number, you get an infinitely large number, which means this line is going to shoot up to infinity as it gets closer and closer to 3. And you can only assume then that this one's going to shoot down, 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 because we're getting infinitely close to 3, but as a negative number. So that's one to play around with. That's one you'll see a lot more in grade 11 and 12 and calculus for sure. It's called points of discontinuity and asymptotes. You can find some stuff in there on my notes in my grade 11 section, or I believe a couple in the full lesson here for grade 10. So let's look at one more here. We have y equals 3 to the power x. So this is what we call an exponential. Again, if you look at this equation, there is no value of x that will ever give you 0, because when x is 0, we get 1. If x is 1, we start to get powers of 3. And if x is negative 1, that means 1 over 3. Or negative 2, that means 1 over 3 squared. So as our exponent goes into the negatives, we are again getting very, very small. We're going to become a very, very large denominator. So we're going to approach 0, but we're never going to get it. We have an asymptote again. This is a big message here as well, because every time you put something to a power of 0, you get 1, which means we have a point right here. Every basic exponential has a point right there. When x is 0, y is 1. And then just look at the behavior. When x is 1, we're already up to 3. When x is 2, we're going to be at 3 squared, which is 9. And you can see that this thing is just going to take off. Exponential growth goes up really fast. And then if we go the other way, we go to a third, a ninth, a 27th, and we get close, 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 but we're never going to touch. So an exponential graph looks like that. Now this one is a fun one. This one's tough to do because you can't just plug in values for one variable and solve for the other. So one good way to do this would be to subtract x squared from both sides, and we'll isolate the y squared. Now in the other video, I simplified it all the way down to y, but in this one, I'm going to leave it as y squared, and we'll just square root our answers. Important aspect of square rooting, the square root of 16 is equal to plus or minus 4, because both of those numbers, 4 squared is 16, and negative 4 squared is 16. So it's important that when we do get our answers, we are going to be getting positive and negative values. So what we'll do here is we'll look at this. We'll go x and then y squared, and then we'll square root all those when we're done. So how about when x is 0? Well, when x is 0, y squared equals 16, which means that y equals the square root of 16, 4, but plus or minus 4. Sorry, that's y squared. Y squared is 16, so here's my y. Y is plus or minus 4. Okay, so let's move left and right of that. What happens when x is, we'll look at what value of x is going to give us y equals 0. Is 16 a perfect square? It is. And 4 squared is 16. So if x is 4, we get negative 4 squared plus 16 means negative 16 plus 16. We get y equals 0. So we get y squared equals 0, which means we get y equals 0. But also remember that if x is negative 4, let me just be really clear here. We have negative 4 squared, also 16. So when x is plus or minus 4, we get 0. So that means right now we have some interesting points on this graph. We have a point here. When x is 0, we have a point here. And then when y is 0, we have a point here, and we have a point here. These are equidistant points. And now, if we try a value outside of those x values, so let's try a value outside of 4, because 4 there looks like a boundary. So let's try, here's our equation. What happens when x is 5? Well, in this case, we're going to get y squared equals negative 5 squared plus 16, which is negative 25 plus 16. So it means y squared is equal to negative 9. But therein lies an issue, because you cannot take the square root of negative 9. There is no solution here. So what that means is there is no solution out here, there is no solution over here, there will be no solution up here, and there will be no solution down here. All of these things are outside of our domains and our ranges, because we can't square root negative numbers. So then what's the behavior of this? Well, pick a point in between 0 and 4. Let's take 3. Just see what happens. When x is 3, we get y squared equals negative 3 squared, which is 9. So we get negative 9 plus 16, we get 7. But that's y squared. So if y squared is 7, it means that y is plus or minus the square root of 7. And if you plug that into your calculator, you're going to get a number less than 3 and bigger than 2. So it means we're going to exist somewhere in between 2 and 3, like here, but a plus or minus version. And we're also going to get that on this side because it's a mirror image, right? If x is negative 3, we get the same scenario. So the shape that we create here, and this is going to be poorly drawn, I'll do my best, is a circle. You get a circle. Anything that has x squared plus y squared in it is either going to be a circular shape or what is called an elliptical shape, which is an oval. You're going to maybe see those in a conic section of Pre-Cal 12 or in some form of geometry later on in your math journey. I don't want you to stress too hard about the nonlinear equations. If you can graph a parabola, awesome. If you can graph an exponential, great, and even a rational. But make sure you can graph slope-intercept form and standard form